One thing we're going to need to deal with here today is just a term in programming known as a reference. So I want to get you familiar with what it means and how you can see it working. So we're going to start with some graphics just so you can visualize how it works. And we don't really need to change too much about it, so I'll just give it a title. So here's the way it works in a reference. So far we've been doing things like this. And maybe I use it to create a shape. And I use the center and I go like, radius 4. So nothing different so far, just, way things have been going. And the difference today, though, is we're going to look what happens if we don't use the new operator. So one thing I mentioned before, some of the terminology you need to know, is when you say new, you're telling Java to go and build the object for you. So it's going to go to the constructor, the one that you've chosen. In this case, I've chosen the one that has just a string in it, and it's going to build that object for me, put it in the computer's memory, and then this variable name window tells me how to find that object it's built and stored in the computer somewhere. So what if I don't build anything? What if I just go, whoops, JCircle, and I'm going to call it reference equals circ. Okay. You can't do this, by the way. Even if I give it the proper things. Because Java is saying, hey, you're waiting for me to build something, but you haven't asked me to make new memory. So I can say, here's a JCircle, and let's use one that's already built. So what's going to happen, though, is this is just a variable name, and it's important to know what that means, is that it basically tells me where it is in memory. So what am I finding in memory? I'm finding circ. And what is circ? Circ is a circle with radius 4 and a center at 0, 0. So this one points to that circle, and so does this. They both point to the same object. So let me show you what happens then if I say window.wait a second, and I'm going to say take that reference and set its fill color to be, sure, yellow's fine. And now let's animate it. You know what, I'm going to just say animate the circle. So here's the original one that's been drawn. And a second later, boom, it turns yellow. But notice that it's actually the reference, this one here, who I said change the color to yellow. I didn't say circle change your color to yellow, but what actually did change was that one that we started with. Now how did it do that? Well, because reference is just telling me where to find the object in memory, it's telling me this object, which is the one we built here. They both point to the same thing in memory. So all it said is go to memory, and whatever you found there, set its color to yellow. So even though I'm not the one who built the object, I can go and find it and still change the color. So references can be tricky because they may have unintended consequences for you if you're not aware of them. For example, these are not two distinct circles. By doing that, I haven't actually created two distinct things in memory. Changing one affects both. Another thing is it can make it can be a great thing to use. It's a tool that you can use in your programs, or it can also work against you if you don't know what you're doing with it. For example, here I have access to the same thing. I didn't need an extra copy of it. If I had that object twice, it might just be a waste of memory, a waste of space in memory. For example, when our school takes attendance, there's a database that has all your names in it, and it keeps track of your attendance. It wouldn't make sense to let every teacher, when they log into the system, to create a new version of that database. Because, for example, that would be a lot of memory if all 100 teachers had access to all 1,500 students. Just think of how much memory that would absorb. The other problem is if it's a copy and the teacher changes it, that doesn't affect anybody else. Nobody else knows what happens to the attendance except the one teacher who changed it. So really what's going to happen is if you're the programmer, you're going to say, you know what, I only want one database for the attendance, and I want everyone else to be able to refer to its location in memory. You mean that on purpose. Okay? But there's other times, like for example, in the classes you're using for graphics, when it makes sense to avoid references. Like this center here. What happens then if I go like this and I say, whoops, I use the center to build that circle, and I go center dot move to 2. Okay, the problem is going to be the center of the circle is this point. Now, if I move the center, does that affect the point and the circle? Let's run it and take a look. It's still right dead center of the screen, so it did not move. That's the way we want it. When this class was designed and built, I made sure that I used new memory when I built the circle. Otherwise, doing this would affect both objects. One of them is like a side effect because you think you're moving the point, but anybody else who's referred to that point is also going to be moved. So it can get really tricky to track down those kind of bugs. If I want to move the circle, all I want to have to say is circle.move, and I don't want anyone else to be affected. So here's what it would look like if I did it that way. See, now it's off center the way I moved it. Okay, so tracking and knowing where your references are is a huge part of programming, and you're going to get away with it for the most part in our first programming course, but the second programming course is really where you start to manipulate these things and you learn just how huge this idea is and how necessary it is as a good programmer to understand them. So today what I'm going to do for you is I'm going to build a program that's going to explore these references for you. I'm going to show you a little bit about it, and then I'm going to ask you to do a hand trace for me. So I'm going to pause the video here. You're going to see it's going to blur back up with the whole program. Okay, here's my program. And what I've done is I've built 4 circles, red, green, blue, and black. And they're going to show up on the screen. We'll wait, I'll change them and animate them to show you what happens. So I want to be able to predict this stuff so that I can show that I understand the way the references are working. So I'm going to make some comments in my code here. Reference 1 will change the red circle. Now reference 2 will change the green circle. It's not generally something you'd want to do in your own program, but again, the purpose of this is that I want to see you understand the way they work. So I'm just going to make the notes here. So I can then follow the work of what's going to happen. So reference 5 refers to reference 2. And reference 2 refers to the green circle. So reference 5 will change the green circle. Okay, because the memory that reference 5 points to is the same that reference 2 points to, which is actually the green circle. So when you go through references, you have to keep going through the references and you trace your way back until you find the actual object that was created. So here are the actual objects that I've created, and again, I know that these are objects, not just references, because they use the new operator to build them. So tracing back, it goes from reference 5 points to reference 2, reference 2 points to an object, so now I know where reference 5 points to. Reference 6 will change, well, if it points to reference 1, and reference 1 points to the red, then this one will also change the red circle. So now that I have my notes here, I can see what's going to happen. Reference 1 is going to have thickness of 3. So reference 1 changes the red circle. Red circle will have a 3-pixel border. Reference 2 is going to change its border color to cyan. So it's green. Reference 2 is the green circle. So green circle will have cyan border. Then it says reference 3 is going to change the radius to 1. So that's the blue circle. Blue circle will have radius 1. Now reference 4 is the black circle. So if I move it -1, 1, then I can just call that black circle will be moved 1 unit left and 1 unit down. Okay, so here are the tricky ones. 5 is actually pointing to 2, but 2 is pointing to green, and we've traced it out here. That's why the notes are handy. So reference 5 is the green circle. So the green circle will now be pink. And here reference 6 is pointing to the red circle, so the border color is going to be green. The red circle will have a green, border. Okay, so Java will do those changes. We'll verify it visually, but we're going to keep stepping through. So, references get changed again. Let's take some notes. Reference 1 refers to reference 3, so I got to go back through my code. Reference 3, that was the last time I assigned it, and it was pointing to blue. So reference 1 will change the blue circle. Reference 2 is pointing to reference 4. Here's the last time I had reference 4, it was black. Okay, reference 3 is now pointing to reference 5, so let's trace. Reference 3 is going to point to this one. And I know in my notes that reference 5 is pointing to the green circle. But I'll just retrace it for you. 3 points to 5, 5 points to 2, 2 points to green. So this time now, reference 3 will, I don't know why I wrote 4 there, that should say 2 of course, will change the green circle. And then if reference 4 equals to reference 6, reference 4 is the black circle here. Sorry, that's not. Reference 4 points to 6, 6 points to 1, and 1 points to red, so it'll be the red circle. And it says red here, sorry, not black. So reference 4 will change the black circle. So 4 points to 6, and 6, according to my notes, is the red circle. Or I could go 4 to 6, 6 to 1, 1 to red. That's the object. Now I'm done. Okay, so let's make some changes then. If I change the fill color of reference 1, that's the blue circle. So blue circle will become yellow. Then here it says the reference 2, which is the black circle that we traced out. The black circle is going to become, well, it'll have a magenta border. And the thickness here is 10. So reference 3 is the green circle. We'll say have a border thickness of 10 pixels. And then reference 4 is the black circle. So black circle will be moved to center at 0, 0. Okay, and then we can verify the changes here when we draw the original circles again. So we're going to step through this in the code now, and I'll show you that our predictions are actually true. If I wanted to know what's the net result on all of these things, I've got it in my notes here. For example, the red circle is going to have a 3-pixel border. And what else happens to the red circle? Green border. And blue circle. Where's my red circle? Oh, that should have been red. Right, because 4 was pointing to 6 and 6 was the red. So if I wanted to do my reds, red will now be, like, add up all the changes, 3-pixel border. That's what happened up here. The next thing that happened to red was green border. And then finally, move to center at 0, 0. And center 0, 0. That's the net result. Okay, well, let's tally up everything from the green circle. So the green circle, first thing that happens to it is I get a cyan border. Cyan border is very light blue, by the way. The green circle is pink. Color changed to pink. And green circle has a border thickness thickness now 10. The blue circle, if I add up all the changes that have happened here, has radius 1. Oops, radius 1. So much smaller. And where else does blue happen here? Becomes yellow. The black circle, if I add up all the changes, move 1 left, 1 down. And I also am going to put a magenta border on it. Okay, so after all those references and all the crazy changes that happened, I can trace it all through. I know what the net result's going to be when my program stops running. It's good practice. We might as well try it again. If we trace up to here, what's going to happen to them? You should try and do this, pause your video and see if you can figure it out up to this point. It's easier than the one I walked through because I took all the changes. So if I animate it here, what's it going to look like? Okay, so if we do try it, hopefully you've had a chance to pause it and give it your own shot. But if I do it at red, this one says 3 pixel border. Then it's going to have a green border. Then green is going to have a cyan border. And it's going to become pink. Blue is going to be, let's see here, radius 1. And it doesn't happen anymore. And black is going to be moved 1 left and 1 down. So after the first set of changes, this is what you should get if you mapped all the references through. So let's run it and verify all this now, because it can be kind of abstract looking at it this way. Maybe I'll pause it for a little longer than that. Maybe I'll give it 30 seconds so that we can verify all these changes. That might be a little long. Let's see if I can do it in 10 seconds with you. And then we'll verify these changes here in 10 seconds as well. See how it goes. Okay. Oops. Okay, so red, green, blue, black. And here's the changes coming. So red has a 3 pixel border and is green. This one became cyan border with pink. Radius 1, and the black circle was moved 1 left and 1 down. Okay, that's what we thought. And there's the final picture. We'll go down here to verify it. Move this. Okay, you can see enough of it there. 3 pixel border, green, and center now 0, 0. Yeah, that's where it ended up. The green circle that was here is cyan border, changed to pink, and its thickness is now 10. That's right. The radius 1 circle for blue, and it becomes yellow. Right? And then finally over here, it moved. It started up where the center was about where my mouse was. It moved 1 left and 1 down. It also has a magenta border now. It's kind of hard to see, but you can see that hot pink around the edge of this black circle. Okay, so we were in fact able to predict all those changes. I will put this file up on the website so you can see as a template. You can play around with the code and run it yourself. But your assignment for this is going to be, I'm going to put a very similar one up, and this is how I want you to trace it. I want you to do this all by hand. So I actually want to see your handwritten comments beside all the references so I can follow how you trace through all the references. Now, of course, you can always run this through your program and make sure that it runs up properly and that it does what you think it's going to do. But ultimately, I'm going to ask you to do this for me without the aid of your computer. So if we sit down for a quiz, I'm going to give you a program like this, and I'm going to say predict what the changes will be using references. You won't have the computer to run it through. You're going to need to do it by hand. So it's in your best interest to try doing this by hand. You can verify it in NetBeans, but really you need to be able to do this without Java telling you what's going to happen by running the program. Okay, so this file is going to be posted on our site, and beside it you'll see it says source code for the assignment. It's basically going to look very similar to this, only there won't be any of these comments in. I'll be expecting you to do that for the hand in.